Hey guys, welcome to another lesson. So today we continue on with the nice question series in the Extension 1 syllabus. So today's question comes from the topic of calculus volumes from the Killara 2022 past paper. Now, it's a nice one. It's actually a blast from the past, but for those that were aware of the old syllabus in 4-unit maths extension 2, there used to be a topic called volumes, and they had harder methods to teach you to assess you with volumes. Now, the question I'll show you today looks very similar to that 4-unit sort of type of question, but hey, now it's in the extension 1 syllabus, so they've sort of dumbed it down a bit, but it still brings back a little bit of nostalgia. Now, before we dive into it, guys, as always, please, if you haven't already done so, like the video, subscribe to the channel, and tell your friends. Also, if you are an Australian student sitting the HSC in New South Wales especially, and feel free to go to our website, nexteducation.com.au for past papers, right? We've got past papers that you could try, past trial papers. Have a go, and if you need solutions, just email us at info@nexteducation.com.au for solutions, guys. Let's get started. All right. So now this question, look at it. It is quite spectacular, right? 4 marks, right, in the Killara extension 1 paper. A donut-shaped, let's get right into it. Donut-shaped pool toy is designed by rotating this circle around the x-axis, right? Find the volume. Now, the diagram that it gives you, I mean, I don't know how you guys feel about it, but I looked at it and I was like, yeah, okay. Yeah, I get it. I don't really know if you can see it, but essentially, when they say a pool toy, we're rotating. Now, the best way for you to visualize it 2-dimensionally, right? So if I can draw a plane better. Now visualize it 2-dimensionally. Now, what is this? That's a circle shifted up with a center of 125, right? Center of 125 and a radius of 12. So something like that. And we're rotating this circle, right? We're rotating it about the x-axis. Now, what would that look like? You can sort of see it sort of creates a donut-like shape, right? That's what this is trying to depict. So the way this is rotating, this is x and this is y, it's rotating about the x-axis. We're spinning it about this line here, right? And where's the circle? The circle's over here, right? Yeah, so the circle's over there and we're rotating it about the x-axis. That's how I want you to visualize it, right? Rotating about the x. So now, how do you do this? The way you sort of attack this question, right? Remember, when we're doing volumes, right? It's basically, actually, I'll do it over here. I'll do it I'll use, I was going to use green, but the donut is green. I'll use blue. Yeah, I'll use blue. Okay, I've got blue over here. So the way maybe I'll use a 2-dimensional shape first. The way you sort of rotate it. So picture this circle here getting rotated, right? Sort of like about the x. Right? It creates like a donut 3-dimension now. That blue there isn't quite doing it, doing its job, but basically it creates a donut, right? So what I want you to visualize is, how do I do this volume? I basically want 2 things. I've got a length over here, yeah, and a length that goes all the way up here, right? So, and actually, you know what? I'll use two different colors. Let me get rid of the shading as well. Yeah, I really want you to picture this, please, right? So, I'll use brighter color so you can see. Yeah, perfect. There's this length here, and then there's I'll use red. Yeah, perfect. So I got a small length of yellow and a small length of red. And what's going to happen is I'm going to rotate both of those lengths about the x-axis. The difference creates the donut. So for example, right, yellow and red, picture, I took a slice over here. If I took a slice over here, then the red goes up to there, and the yellow goes up to there, right? So as that blue rotates around the x, it creates a slice of the donut, right? A really thin slice of the donut, where the volume of that slice would be the slice as it relates to the red minus the slice as it relates to the yellow. So, guys, what am I trying to tell you, right? In terms of volume, right? the volume of one slice. So picture that blue, right? Actually, stay with the blue. Stay with me, right? So if you can, now let's see if I can do this successfully, right? So if I had a mirroring circle over here, just for you to visualize first, right? And I mirror the blue slice. Right, picture me creating an annulus, right? A circle within a circle, right? And picture this blue sort of annulus disc, right? Sort of changing in size across the circle. So how does it change in size? This side here sort of goes from small to the center and all the way to here. So it sort of goes small and big and creates, keeps rotating and creates a donut as you roll around. Now, I need to find the volume of this of one slice, and then I'll integrate it with respect to the limits, right? So, actually, maybe before I begin, guys, different graphic. Let's just find the limits, right? So if this, no, can I draw a circle that's a little bit bigger? Right. Just so I know what the limits are. So let's say this one here is 125. And I know that that's a radius of 12. So then that's negative 12. Okay, that's 12. So got my limit. So actually, because it's symmetrical, I'm going to go volume equals from 0 to positive 12 and double it, right? But okay. Now, let's go to this volume, right? So the volume of one slice, right, equals to, the volume of one slice equals to the volume of the yellow, volume of the red minus the volume of the yellow, right? So it sort of looks like, so the volume of the red would be pi r squared on the red minus pi r squared on the yellow, right? Now, what is red r and what is yellow r? This is the key, right? So if you can sort of picture, right? So, and I'll zoom in to demonstrate this, right? This is, so let me get rid of this blue slice here. Now, right? So let's say this is R, yellow, and this is R, red, right? Both of those represent, if you sort of take them to where the blue is, right? It represents the Y values, right, of the circle. There's sort of two Y values there. So what I'm going to do is basically I'm going to try to make Y the subject on this circle. Now, what was the formula of the circle? Is x minus 125 squared plus Y squared equals to 144. Guys, when I make Y the subject of this, it'll give me, now, it's going to have plus minus in there, right, inevitably. And the plus minus represents the small and the big of the yellow and the red, right? The minus case will be the yellow, the positive case will be the red, right? So let me take this formula now. Yeah, let's take this formula. Okay. Let's take this formula down here. Yeah, off to the side somewhere. Yeah, let me make Y the subject. Yeah, 144 minus x minus 125 squared, and then Y equals to plus minus square root 144. Now, this question's worth 4 marks, right? Which is quite substantial for a 3-unit paper. It's only out of the 70 marks, so it's like 6-7% of the test itself, right? Maybe 5-6%. Guys, that's the Y value. Now, see the significance of the plus minus, right? Just to be absolutely clear, the plus case is the red R, and then the minus case is the yellow R, right? So what I end up subbing into, the two R values there and there are going to come from this Y value here, because you can see in the diagram, right? Yeah, if R was like the blue line was representing the volume that I need to, representing the differences in the Y values, the smaller R value, right, is the Y value with a minus, and the larger y value, right, which is the red one, is the y value with a plus. So what this means, guys, if this is volume of one slice, I know therefore total volume equals to, now I'll factorize the pi out, yeah, and I'm going to go from the limit of -12 to 12 first, right, and then r squared on red minus r squared on yellow dx. Yeah, let me just check that. Perfect. All right, and now what goes into these two parts here are these guys here, right? Just remember, the red one is the plus version and the yellow one is the minus version, right? So when I do this, so it becomes pi, yeah, y squared. Now let me just check this. I made, oops, guys, just to, got my algebra here wrong. So this was y. Yeah, let me just clean this up. My apologies. This was y, right? And this is x. So when I make y minus 125 squared equals to 144 minus x squared only. Yep. And then y equals to plus minus root 144 minus x squared plus 125. Perfect. Yeah, so same deal. So minus yellow and red is a plus. Okay. Sub that in, right? So sub this guy. Yeah. Sub that guy in. All right, let's do it. Yeah, let's do it. So what I want is for the red case, yeah, to be let's say root 144 minus x squared plus 125 squared minus exactly the same, but with a minus. Yeah, so minus root 144 plus, oh sorry, minus x squared plus 125. Okay, all right. Now, I have no space, right? Let me just move, actually. You know what? Let's keep going. Let's see where this takes us. All right, I have some algebra to do. Oh, sorry, between the limits of now actually. So it's between -12 and 12 because it's symmetrical 12 and 0, and just put a 2 in front. Yeah. So it becomes like 2 pi 0, 12. Let me just check that. Perfect. Let me expand this. So what do I get? When I expand that perfect square, I get 144 plus x squared plus 2 times that's 250 root 144 minus x squared. Actually, you know what? No, I'm going to leave this limit. Sorry, I'll show you why. It's actually easier for me to explain when I leave the limits as they are. Okay, well, let's leave the limits. All right, so perfect square, 1 plus 2 times that, and then plus 125 squared, whatever it is. Don't care because it cancels out, right? So that's the red, and minus the yellow. The yellow is essentially exactly the same. So I'm going to be lazy for PowerPoint purposes, right? Ungroup that. Just going to copy and paste that. Yep. And then move that gently over here. Delete that. Yeah, and the only difference between red and yellow is that the perfect square expansion in the middle is minus, right? So I'll get that. Is that okay? Now let me move this back on screen. Hey guys, you know what? I'm going to start a new slide with this. So when I start a new slide, I'm just going to delete things I don't need. Yep. I'll take this. Okay. So dx. Move over. All right. Oops, too much. All right. Now you can see, right, in terms of algebra, this guy goes away with this guy goes away with this guy, and in the middle you got 250 square root minus 250, so that's 500. And maybe take out the 500 pi, integral minus 12 root 144 minus x squared dx. Now, almost there. Once you get here, to integrate the square root of 144 minus x squared. Now, unless the limits are really nice, which they are in this case, if the limits weren't nice, you'll have to use extension 2 method to do this, right? And for those that know, we're using trig sub, right? Yeah, one of the hardest versions of trig sub where you let x equal to what, 12 sine theta or cos theta, right? And that would help us integrate this. But in this case, it's special, right? Because if you think about the graph used to integrate this guy, right? This function here is a semicircle. Yeah, and it wants to find the integral between negative 12 and 12, which is essentially the area under the curve. Because that's a semicircle, I don't need calculus to find the integral of that. I can just use measurement, right? We know that this is essentially half of a circle, so it'd be pi r squared divided by 2. It's as easy as that. Yeah, pi r squared divided by 2, which we know to be what? So that's if you do 500 times that, expand it all out, you should get 36000 pi squared units cubed. That's the answer. Guys, what an amazing question, right? I really like. It is nostalgic in that now the shape they call this, right? So a 2-dimensional sort of circle on a circle is called an annulus. A 3D donut is called a torus. The torus was a classic shape of the old extension 2 syllabus. It's no longer done with the volumes techniques that we know. It's unfortunate, but that's how you do it. So let me recap, right? So because we have a circle rotating about the x-axis, right, it creates a donut shape. How do you find the volume of a donut? You basically take one slice of that blue line there, you split the blue line into yellow and red, and you rotate those about the x, which means when I find the total volume, it will be pi r squared on the red minus pi r squared on the yellow. To find the expressions for the radius, right, the radius is equal to the y values, right? The y value, make y the subject in the equation, and you get plus and minus. The plus version is obviously the bigger radius. The minus version is the smaller radius. Rotate it. Guys, that's how you do it. Hopefully that was nice. That's it for the video. Once again, if you like that, please like the video, subscribe to the channel, tell your friends. And if you want past papers, please email us or so go to our website or email us and then email us for the solutions. Guys, see you later.